Okay, so for the title for these notes, you're going to say making a piecewise function differentiable. So we are making a piecewise function differentiable. This is very similar to when we made a piecewise function continuous, but making a piecewise function continuous only worked with one piecewise function. To do this, we have to work with two because we have to work with the original function and its derivative. So it's just like a two-step process instead of a one-step process like what we did before. So first, I'm just going to do two examples because I don't think that we need to write out explanations. I think they're kind of intuitive. So first we're going to find B and C so that f of x is differentiable for all real numbers. And all real numbers, they call it double bar R sometimes. Have you guys seen that symbol before? Yeah. That just means negative infinity to positive infinity in set notation instead of interval notation. So same thing, just slightly different notation. What? Yeah, it has to be continuous to be differentiable. So yeah. All right. So f of x is 3x squared plus 4x, and that's if x is less than or equal to 1. And then the other part of the function is 2x to the third plus bx plus c, and that is if x is greater than 1. So if they had given us this function and we had to first show that it was continuous, what would we do to show that it was continuous? Set them equal to each other while plugging in 1. Okay, so we would say 3 times 1 squared plus 4 times 1 equals 2 times 1 to the third plus b times 1 plus c. So if the graph is continuous, this will be a true statement. And for it to be differentiable, I need that to be a true statement. Okay, so that's my first step. Can we simplify that? Yes. So we've got 3 plus 4 is 7. 7 equals 2 plus b plus c. And so really we have 5 equals b plus c. So I subtracted that 2 over. So that is our first set of information. That is us just making sure that it's continuous because it has to be continuous first. Okay. What do I normally do next to see if a piecewise function is differentiable? I take the derivative. So I'm going to go ahead and do that. And what is the derivative of the first one? 6. Okay, so it's that if x is less than or equal to 1. How about the derivative of the second one? 6x squared plus b, okay? And that's if x is greater than 1, okay? Yeah, so if we take the derivative of bx, then just b. All right. So if this is differentiable, what should happen? They should equal when I plug in 1. Okay. So I'm going to say 6 times 1 plus 4 equals 6 times 1 squared plus b. And can we simplify that at all? So we have 6 plus 4 is 10. 10 equals 6 plus b. Okay. So if it's differentiable, this has to be true. Right? So our b equals 4. Then we can use that information to go back up here and solve for c. So we're going to say 5 equals. 5 equals 4 plus c. And so c equals 1. And then we're good. That's it. Yep. Do the steps make sense?
Yeah.
So you're mimicking the same steps that you just did. We're just using them to set up a system of equations to solve. Yeah. Well, it depends on the instructions. So in these instructions, they literally just said find b and c. So we did. If they want you to plug it back in and say what function would then be differentiable, then you could plug the b and the c back in and say the function f of x equals and actually have those numbers in it. Then you could clarify that. But typically they just want you to find the letters. And this sort of thing I could definitely see as a multiple choice question because there's the work to be done, and then either you get the right answer or you don't. Yeah. All right, we're going to do one more example just to make sure that was okay and that we can do a slightly more difficult system of equations. So this example is going to say find a and b this time. So that f of x is differentiable on negative infinity, infinity. This one's actually not more difficult than the other one, but we're going to do it anyway. All right, step 1. Set them equal to each other while plugging in 2. So we have I'm waiting for you to tell me what you have.
4a plus 10.
If it was a plus, yeah, it's a minus. Negative 8 plus b. Okay. So 4 minus 12. Four minus 12. Oh, you thought this was a 6?
I thought it was too.
That's a B, sorry. To be fair, lots of students get problems wrong on a regular basis because they can't read their own handwriting. Yeah. Alright, so I could simplify that a little bit. I might just call that 4a minus b equals negative 18. Are we cool with that? So I subtracted the b over to the left side, I subtracted the 10 over to the right side, and now what should I do? Wait, I have 2 variables. Can I solve this? I can't solve this. So I'm going to move on to the next step. So, what do I do next?
Plug negative.
Derivative. There we go. All right. F prime of x is. Yep. Oh, that's it. If x is less than 2.
And 2x minus 6.
X is greater than or equal to 2. So we're going to have 2 times a times 2 equals 2 times 2 minus 6. 4a equals -2. So a equals -1/2, -2/4, which becomes -1/2. Okay. Yeah, and then we can take that and we can work here. We actually know that 4a equals -2, so if you want to be tricky and just plug -2 in for that whole 4a. Oh, we could do that instead. So I'm going to say -2 minus b equals -18. Did I lose anyone when I did that? So I just plugged 4a in for 4a. That way I didn't have to deal with the fraction. And you add 2 over, so -b equals -16. And then b equals 16.
So did you divide that by x?
Yes.